So in this video, I'll be going through the June 2018 paper 3. Let's make a start. Question 1, the scatter diagram shows information about 12 girls. It shows the age of each girl and the best time she takes to run 100 meters. And we can see that plotted on the graph. The first question is write down the correlation. So the correlation of this, we can see the points are coming down. So we could even draw a line of best fit just to see that a little bit better. Get your ruler out, draw a line through as many points as possible. So that looks fine there. If I draw a line straight down, get rid of my ruler, the line is coming down, so it's a negative correlation. And if you can't remember that, you could just remember this little trick. So if it's going up, it's positive. If it's going down, it's negative. And if you can't remember that, you can draw like a straight vertical line next to it, and this looks like the letter N. Whereas if you did it here, this does not look like the letter N, it's backwards, so it's a negative correlation. So we can just write negative there. Alright, Christina is 11 years old. Her best time to run 100 meters is 12 seconds. The point representing this information would be an outlier on the graph. Explain why. So 100 meters in 12 seconds for an 11-year-old. So she is 11, which is there. She does it in 12 seconds, and you can see that point there lies very far away from the line of best fit and the rest of the points. So why is it an outlier? Because it lies, because the point is far from the line of best fit. Debbie is 15 years old. Debbie says the scatter diagram shows I should take less than 12 seconds to run 100 meters. So she's 15, which is there. Does it take her less than 12 seconds? Well, it's a little bit unreasonable to stretch beyond the data. So you can see the data is actually from here till here. That's the data we have if you look within the points. We don't actually have any data out in this region. So because we don't have any data in this region, we can't make that estimation. So the point, and the way we would word that is, the point is outside the range of the scatter diagram. Expand and simplify. So just going to expand out the brackets in this one. 5p plus 3 minus 2, 1 minus 2p. So with the first one, we're going to do 5 times p and then 5 times 3. So that becomes 5p plus 15. And the second one, the only thing you have to be careful of is the negative. So that's minus 2 times 1 and then minus 2 times minus 2p. So that becomes minus 2 plus 4p. And we can collect the like terms, so that's going to be this one and this one to start with. So that's going to be 9p, and then we're left with 15 and minus 2, so that's plus 13. Moving on to the next one. Here's a trapezium drawn on a centimeter grid. On the grid, draw a triangle equal in area to the trapezium. So the first thing we need to do is find the area of the trapezium. Now, to find the area of the trapezium, the formula we use is, just move that up, a half a plus b times height. So in this case, the height can be, I'll use a different color in fact. That is going to be the height for us. So the height here is 4. A is going to be this value here, which is 2. And b is going to be this. It doesn't matter which way a or b is, so that's going to be 6 squares across. So if I now plug that into my formula, that's going to be 2 plus 6 times that by the height, which is 4, and that gives us 18. Now we know the area of a triangle is what they want us to draw, but we know the area of a triangle is base times height divided by 2, so we know 18 is equal to base times height divided by 2. If I multiply each side by 2, I end up with 36 is equal to base times height. So I need something where the base times the height is equal to 36. Now, two numbers that multiply to give us 36, that can be 2 and 18, but we can't fit something that's 18 wide or high on this grid. So we can try 3 and 12. That seems too big as well. We can try 4 and 9, and then we have 6 and 6. So we can go with 6 and 6. So we pick a point anywhere, and we're going to go 6 across. And then we know the height of this triangle is going to be 6 as well. So we can then draw that like so. There we go. And if you find the area of this triangle, which is going to be base times height divided by 2, that will be equal to the area of the trapezium. When a biased six-sided dice is thrown once, the probability that it will land on 4 is 0.45. The biased dice is thrown twice. Amir draws the probability tree diagram. The diagram is not correct. First throw, second throw. Okay, write down two things that are wrong with the probability tree diagram. So the first thing I can see is probability should add up to 1. This and this don't add up to 1, so we can write that first throw does not add to 1, and we can write that 0.65 plus 0.25 is equal to 0.9. And then the other problem we can see is the probability of landing on a 4 is 0.65, which is there and there, but then here that it's the wrong way around. So this and this have been written the wrong way around. So the way we can write this is the first branch on the second throw, just to be clear. So it's the first branch on the second throw has the probabilities reversed. It's a little bit hard to write on here. So there we go, that's that one done. So we have a right angle triangle, work out the size of A, B, C. So we can start with labeling this triangle. Let me just grab a different color. So that's going to be opposite, hypotenuse, adjacent. We don't know anything about this side, so we can cancel that out. And we can call this angle that we're trying to find X. So we're left with A and H, so hopefully you're starting to think something like that. So we're going to use a cosine rule, so that's going to be cos X is equal to 7 over 11, and then we have X is equal to the inverse cos of 7 over 11, and that to one decimal place is 50.5 when you put that in your calculator. So the length of side AB is reduced by 1 centimeter. The length of side BC is still 7. Okay, so AB is reduced by 1. Will the value of cos ABC increase or decrease? Now, you want to be careful with this, because this line here is very important, what it's asking. It's saying, will the value of cos ABC. So remember, cos ABC is what I've called X there. So if I look back, let me just use a different color, in fact. If I look back at this, what I've actually said is cos ABC is equal to 7 over 11. And now what they're saying is cos ABC is equal to, AB has been reduced, so that is now going to become 10, so that's now 7 over 10. So if you now look at it, will the value of cos ABC increase or decrease? Well, going from here to here, the value is increased, because if you type this into your calculator and convert it to a decimal, that is 0.7. And if you type that into your calculator and convert it to decimal, that's 0.63. So essentially you can do working out like this down here, and then you can say that 7 over 10 is greater than 7 over 11, so it's increased. It's just one of them questions. You have to read it properly. It's not asking you to find the angle, because if you were to work out the angle you work out for this is actually 45, and the angle for this is 50.5. So that's actually a decrease, but that's not what the question's asking, so just want to be careful on. There are some counters in a bag. The counters are red, blue, or yellow, or red. Bob is going to take a counter from the bag. The table shows the probability that the counter will be blue or yellow. Again, I told you probability adds up to 1. So if probability adds up to 1, 0.45 plus 0.65 adds up to 0.7. So we know that this side must add up to 0.3. Whatever it is, that's what it must add up to. There are 18 blue counters in the bag. The probability that Bob takes a red is twice the probability that he takes a white. So whatever we don't know in maths, we label it x. So if I label this x, this must be 2x, because we're told here the red is twice. Work out the number of red counters in the bag. Okay, so we know probability adds up to 1. So we have 2x plus 0.45 plus 0.25 is equal to 1. If I collect the like terms, that's 3x plus 0.7 is equal to 1. If I subtract 0.7 from each side, I get 3x is equal to 0.3, and I get x. If you do 0.3, divide that by 3 on your calculator, you end up with x is equal to 0.1. Now work out the number of red counters. So the probability of it being red, so if I just write probability of it being red is going to be 2 times x, which is 0.2. It's asking me to work out the number of counters in the bag. So we know that there's 18 blue counters. That's all we've been told. So we know 18 counters does make up 45%. So if you want to work out how much the entire bag has, we can divide each side by 0.45. So if I divide this side by 0.45, I get 1. If I divide this side by 0.45, I get 40. That means altogether the bag has 40 counters. Of them 40 counters, 0.2 are red, so that will be 40 times 0.2, which is 8. Moving on to the next one. A marble is going to be taken at random from a box of marbles. The probability that the marble will be silver is 0.5. There must be an even number of marbles in the box. Explain why. Because if there's an even number of marbles, like 2 or 4, the probability that of picking this is 1, this is 2. But if it was 3, it would become 1.5. Now you can't have an odd number of marbles. It has to be one whole. So you can just write marbles can only be whole numbers. You can't have half a marble. Cool, so that's that one done. 7. Solve this. So straight away, hopefully you can see that whenever you have fractions, you want to try to get rid of the denominators. So in this case, if I write that out, 5 minus x over 2 is equal to 2x minus 7. I want to multiply both sides by 2. And when I multiply the left by 2, it cancels this out. So we are then left with 5 minus x is equal to 2 bracket 2x minus 7. If I expand them brackets, I end up with 4x minus 14. Now if I add x to this side and add x to this side, I end up with 5 is equal to 5x minus 14. And then I can, oh, sorry, let me just fix that. And then I can add 14 to each side. And I get 19 is equal to 5x. And finally, I can divide each side by 5. And I get x is equal to 3.8. Right, moving on to question 8. ABCD is a pentagon. BCD is 2 times ABC. Okay, so this angle here is twice whatever this angle here is. So if this is x, this is 2x. Work out the size of BCD. Okay, you must surely working out. So we can see what we've been given is a pentagon with all its interior angles, so the angles inside. Now to work out the sum of interior angles, so that's how much all the interior angles add up to, there's a formula we can use, which is n minus 2 times 180. This will give us the sum of interior angles, so we can then find the sum of interior angles. So that's going to be, how many sides are there? There's 5 sides to this. 5 minus 2 times 180, which then gives us 540, which then means all of this, all these angles, so that's 115 plus 125 plus 90 plus 2x plus x is equal to 540. If I collect the like terms, so that's going to be 330 plus 3x is equal to 540. And then I can subtract 330 from each side, and that'll give me 3x is equal to 210. I can divide each side by 3. Now that's x is equal to 70, but the question asked us to find BDC, and that's 2x. So our answer is going to be 2 times 70, which is 140 degrees. Question 9. Work out the value of t. So in this case, it's just the case of substituting this into your calculator, really. So we can write that as t is equal to w, which is 5.6 times 10 to the power of minus 5. Divide that by, I'll use brackets here, 1.4 times 10 to the power of minus 4, and then the cube outside. And you would type that into your calculator and get your answer to three significant figures as 4.52 times 10 to the power of 3. Now it says W is increased by 10%, D is increased by 5%. Now you've got to remember, percentage is out of 100%, so if this is increased by 10, this then becomes 110%, and as a decimal, that's 1.1. And same with this, percentage is out of 100. If it's increased by 5, that becomes 105, which is 1.05 as a decimal. So it says the value of t will be increased because both of these two are increased. Lottie is wrong, explain why. So in this type of case, well, you've got a calculator, you can sub these values in and figure that out. So what that would look like is, in this case, very similar to above with a slight difference. So you type in 5.6 times 10 to the power of minus 5. This time we're going to times it by 1.1 because we're increasing W by 10%. And at the bottom, this is where you need to be a little bit careful because it's d cubed, so d is what's been increased, so it's 1.4 times 10 to the power of minus 4 times 1.05 because d is now increased by 5%, and then you're going to cube it. So that then becomes 4.4 times 10 to the power of 3. And now you can see that it has been decreased and not increased because this is 4.4 times 10 to the power of 3, and that's 4.5. And then you can just write here that 4.4 times 10 to the power of 3 is less than 4.5, what was it, 5.2? Yep, times 10 to the power of 3. Moving on to the next one. There are 3 lamps. Lamp A flashes every 20 seconds, lamp B flashes every 45 seconds, lamp C flashes every 120 seconds. The 3 lamps start flashing at the same time. How many times in 1 hour will the 3 lamps flash at the same time? So in this case, we want to find the lowest common multiple across these 3. So we've got a 20, 120, and 45, so we can list out the multiples for A, B, and C. So you can list out some multiple 2, 4, 6, 80, 120, 140, 160, 180, and so on. And with B, we have 45, 90, 135. You can use your calculator to do this. 225, 270, 315, and 360. And then you can just write a few for C as well and see which ones you can find that match up. And hopefully you can see that this 360 here, I should have used a slightly wider one, matches with this one here. And then if you carry on with this, it's the 2 times table. So at some point you'd hit 362. So that's 360. So we know that they all flash at the same time every 360 seconds. So that means if you do 360, divide that by 60 to get it in minutes, that means every 6 minutes all these bulbs flash at the same time. And they want to know how many times this happens in an hour, so we can then do 60, because there's 60 minutes in an hour, divide that by 6, that means 10 times. So 10 times in an hour they flash at the same time. So in 2003, Jerry bought a house. In 2007, Jerry sold the house to Mia. He made a profit of 20%. In 2012, Mia sold the house for $162,000. She made a loss of 10%. Work out how much Jerry paid for the house in 2003. So we have 2003, 2007, and we have 2012. Now with this question, you want to work from the most recent date backwards, because that's the only place we've got this price. So we know that she sold the house for 162,000 and she made a loss of 10%. So we know this is the equivalent of 90%. So that means she must have paid. So we need to work out how much 100% would be in this case. So we know that 162,000, 162,000 is what I'm supposed to say, is equal to 90%. We can work out 1%. So divide each side by 90. So 162, just do that on your calculator, divide it by 90. You'll end up with 1800, and then to get it to 100%, that is going to be 180,000. Okay, so 180,000 is how much she would have bought the house for. Now it says Jerry sold the house to Mia. He made a profit of 20%. So he sold the house to her for 180 because that's how much he bought it for. So we figured that out. But the price he sold it at made him a 20% profit. So this actually represents 120%. So we know 180,000 is equal to 120%. We want to work out how much he paid for the house because that's how much you would have got it for in 2003. So to get that to 100%, we can again go to 1%. So divide each side by 120. And that gives us 1,500. And if you go to then 100%, that's 150,000. So he must have paid 150,000 for the house. So that would have been how much he got it for in 2003. The graph shows the volume of liquid in a container at time t seconds, volume, time. Find the gradient of the graph. So in this case, it's asking us to find the gradient. You want to pick a nice point along the graph. And what I mean by a nice point is one that you can read off easily in the x and the y-axis. So this here, for example, would be a nice point because I can easily read it off as 10 here and 4 here. It's not halfway between. Once you've picked that point, you want to go across and again find a nice point. In this case, a nice point seems like it's going to be that one there because this point up here can again be read off nicely. 16 here and 8 here. So I've gone up from 10 to 16 by 6, and I've gone across from 4 to 8 by 4. So that means the gradient of this graph is going to be the change in y, which is 6, divided by the change in x, which is 4. If you want to write that as a decimal, you can write that as 1.5. Again, you can type that into your calculator. So then it says explain what this gradient represents. Well, you can see it's the volume time graph. So it means that every 1.5 seconds, every second, 1.5 liters of volume of, what is it, liquid? Of liquid, yep. 1.5 liters of liquid is added to the container. Then it says the graph intersects volume axis at L is equal to 4. So that's basically referring to this point here. It's saying what's going on here? Because the graph seems to start right here rather than at 0. So what this means is this container already had 4 liters of water in it before we started filling it. So explain what the intercept means. So it means the volume of liquid in the container at the start. Here are two similar solid shapes. Surface area of shape A to surface area of shape B is 3 to 4. The volume of shape B is 10 centimeters cubed. Work out the volume of shape A. Give your answer correct to 3 significant figures. Now what you want to remember here is to calculate the surface area of something. It's normally something like the width times height. So we can say it's going to be x times x, which is basically x squared. And to work out the volume of something, it's normally width times height times length. So it's going to be x times x times x, which is x cubed. That's something you need to remember with questions like this. So it says the surface area. So we have shape A to shape B. If you know the surface area, they've told us is 3 to 4. With the volume, they've told us the volume of B is 10. and they want us to work out the volume of A. So, well, how do I go from B to A in the case of surface area? Well, how do I go from 4 to 3? So I can do 4 divided by 3. So in this case, I'll have to divide by 1.333 to go this way. So that represents x squared, because remember, it's the surface area scale factor. So then I can work out x by square rooting this, which is 1.1547. And then I can cube this to work out the volume scale factor. Remember that there. And that is 1.5396. So that means to go from here to here, I need to divide by 1.5396. And that to three significant figures becomes 6.50. Moving on to the next one. There are 16 hockey teams in a league. Okay, each team played 2 matches against each of the other teams. Work out the total number of matches played. So each team is going to play, they're not going to play against themselves, but they're going to play every other team. So if there's 16 teams, that means each team is going to play 15 matches. And how many teams are there altogether? 16. So it's just a case of 16 times 15, which gives you 240. Question 15. The graph shows the speed of a car in meters per second during the first 20 seconds of a journey. Work out an estimate for the distance the car traveled in the first 20 seconds. Use 4 strips of equal width. So we have been given some instruction here. 4 strips of equal width. So, well, we know the bottom, the area under the graph represents the distance, and it says 4 strips of equal width, so we can see there's 20 altogether along the x-axis, so that would mean I'm probably going to need something here, 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 and here. There shouldn't be any other way of doing it because they all need to be of equal width. So in this case, I'm going to draw on the graph. Let me just use a different color. So let me just draw that again. So again, use a pencil and a ruler to do this, and then in this case it'll be a straight line down that way. So that's a triangle, and we'll label that as A. So the next one is going to be a trapezium. The next one is also going to be a trapezium. It's a little bit hard for me to draw them perfectly straight on here, but in the exam you want to use a pencil and a ruler to do this. And that is B, that is C, and that is D. So A is a triangle, which is base times height, so we know the base is 5. The height looks to me like it's 22, and we're going to divide that by 2. And we're going to do the same with B, but this time it's a trapezium, so it'll be a half A plus B, so that's going to be 22 plus 28 times the height, which is 5. For C, it's going to be again similar, a half A, which is 28, plus B, which is 30. So I should probably label on where I'm getting these from. So that's my 22, that's my 28, that's my 32, and that looks like it's 35. Again, the width at the bottom is the same, and finally for D we have a half, so that's going to be 32 plus 35 times 5. So type all these into your calculator. So I'm just going to do that now. 5 times 22 divided by 2. That gives me 55 for that one there. The next one is a half. 22 plus 28 times that by 5. That's 125. The next one, just change that to a 32. That's 150. And for the last one, change that to a 35. And that is 167.5, and then you would add all these together on your calculator, so that's 55 plus 125 plus 150 plus 167.5, so that's 55 plus 125 plus 150 plus 167.5, and that gives us 497.5 meters. Okay, so is your answer to Part A, an underestimate or an overestimate. So the reason it's an underestimate is you can see here, I haven't taken this section into account because we're only estimating. So it's actually an underestimate. Again, here I've missed some bit. Here something's missing as well. And just a tiny bit there is missing. So that is why it's an underestimate. So let me just zoom back out and go back to this question. So here you would start by saying it's an underestimate as some parts below, as some below the graph are not included. Question 16. The nth term of a sequence is given by an squared plus bn, where a and b are integers. The second term of the sequence is -2. The fourth term is 12. Find the sixth term of this sequence. So if I was to write that out, n, so the second and the fourth, and they want me to find the sixth, and they've told me the second one is -2, and the fourth one is 12, and the sixth one is what I'm trying to find. Okay, and they've told me that's the formula they've used to figure it out. So in this case, if I use the formula an squared plus bn, so I know n here is 2, which comes from this first line here. So that's going to be a2 squared plus b times 2. That can be written as 4a plus 2b. And in this case, n is 4. So that's going to be a4 squared plus b times 4. And that can be written as 16a plus 4b. And that gives us 12. And in this case, that gave us the -2. And you can hopefully see that these two can be written as simultaneous equations now and solved. So if I write the first equation out, so that's going to be 16a plus 4b is equal to 12. Now with the second equation, I can make b the same by multiplying it by 2. So that will then become 8a plus 4b is equal to -4. And now I can subtract all of these, so that becomes a 0. That becomes 8a, which is equal to 16, which means a is equal to 2. And now I know what a is, I can find b by substituting it into one of the equations. So if I did something like 16 bracket 2 plus 4b is equal to 12, and that becomes 32 plus 4b is equal to 12, and b is equal to -5. So now I have that as well. So if I now write my original equation, an squared, so if I write my original equation here, which is an squared plus bn, so that now becomes an squared, which is 2n squared, minus 5n. So now they wanted me to find what is the value when n is 6, so I can sub that into here, so I can do 2 bracket 6 squared minus 5 bracket 6, so that becomes 2 times 36, because 6 squared is 36, and 5 times 6 is 30, and your answer then becomes 42. Here are the first 5 terms of a different quadratic sequence. So they've told us it's quadratic, so it's not going to be going up linearly. So for example, to go from 0 to 2, you add 2, but from 2 to 6, it goes up by 4, and then from 6 to 12, it goes up by 6. It's not going up in a linear manner. Now the way quadratic equations work is they all boil down to this an squared plus bn plus c. Let me just use a different color now. So when n is 1, so the value of n is 1, we have a plus b plus c, because that becomes a 1 squared plus b1 plus c. When n is 2, that becomes 4a plus 2b plus c. And when n is 3, that becomes 9a plus 3b plus c. And the reason I'm doing this is just so you can see how this actually works. Now, in order to go from here to here, we're adding 3a plus b. so that A becomes a 4A and that B becomes a 2B when we do that. And then to go from here to here, we're adding 5A, which makes the 9, and then we're adding B, which makes the 3B. And then, if we were to find the difference between these two, that would be 2A, because the B's are the same. Now, if I write out the sequence that we've been given, which is 0, 2, 6, and 12, now to go from here to here, we add 2, from here to here, we add 4, and then if I was to find the difference between the two of these, that's going to be 2. So now we can pair these values up. So this is equal to this, and this is equal to this. Now hopefully we can find some values from that. So if you look at the bottom one first, we have 2A is equal to 2. That's the yellow bit, which means that A must equal to 1. So I've figured out what A is now. And now I need to find B and C. Now if I look at what I've highlighted in blue, that's going to be 3A plus B is equal to 2. I know what A is. A is 1. So that's going to be 3 plus B is equal to 2, which means that B is equal to minus 1. And now finally, if I look at what I've highlighted in green, so that's A plus B and that one. So that means A plus B plus C is equal to 0. We know that A is 1, B is minus 1. That already gives us a 0, so that means C must be 0. So if we now come back over to this equation up here, we now know that A is 1, so we have n squared. We know that B is minus 1, so that's minus n, and we know that C is 0, so your answer is n squared minus n. Hopefully you can see with the highlighter, me highlighting this with the highlighter has made it a little bit easier to follow. So moving on to question 17, work out the length AD. Give your answer correct to 3 significant figures. Okay, if I'm looking at the upper triangle ABC, I've only got an angle and a side, so there's not much I can do at the minute. So you want to start thinking about side angle, side, 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 side. So you hold sine and cosine rule when it comes to questions like this. So if I look at the lower triangle, which is, I just get my highlighter, this one here, I've got two sides. I've got one side and two angles, so I can actually do stuff with this. Now it would be useful if I use this triangle here to figure out what this length here is, because then I would, for this triangle, have two sides and an angle to work with. So we'll start off by, the only thing we can really figure out is this here, so let's call this X, and you can start thinking about your rules of, well actually we'll call it C for now. You can start thinking of the sine rule, sine C over C is equal to sine B over B. So if you use them rules, we have sine C, which is 34, divided by C, which we don't know, and then we have sine 109 and 12.5. So now if you rearrange this, move the C over to that side, so that will be C is equal to sine 34 all over sine 109 divided by 12.5, and then that gives us the value of C as 7.39267. So now we know this side is 7.39267. So now I'm just going to rub that off. Now we have two sides and an angle between them. We can now use that to figure out the missing part. So now the equation we're going to use to find out the missing part, because we have two sides and an angle between them, is the cosine rule. And that can be written as a squared is equal to b squared plus c squared minus 2bc cos A. So we can then label the missing side that we're trying to find as A. I'm just going to relabel this triangle so it's less confusing. I'll call this A. I'll call this B. And I'll call this big C. So that's C, and that's B. So now if I substitute these values in, I can see what, I don't know what A is, so we can write A squared is equal to, B is 7.3926, squared minus c, which is 11.4, squared minus 2b times c, so that's 7.3926 times 11.4 times cos 86. If you substitute that into your calculator, you'll end up with a squared is equal to 172.8539. We can square root that and we get 13.1 to three significant figures. Show that the equation x cubed plus x is equal to 7 has a solution between 2 and 7. So when you substitute 1 into this, so we can do it like this. So we can have 1 cubed plus 1. And if you do that on your calculator, well, you don't need a calculator for this. You can just type 2 there. And then you can do 2 cubed, which is 8 plus 2. And that gives us a 9. And then we just want to write a statement that the answers for these two is 1 is below 7, 1 is above 7. So it must be in that range. So the value 2 and, sorry, that shouldn't be 9, that should be 10. 2 and 10 are below, so the 2 is below and the 10 is above 7. So the solution must be between 1 and 2. Show that the equation x cubed plus x is equal to 7 can be rearranged to give that. So in this case, we have x cubed plus x is equal to 7, subtract x from each side, and you can already see it's looking very similar to that. And then finally, you can just cube root each side, so that would be x is equal to the cube root of 7 minus x. So starting with x0 at 2, use the integration formula 3 times to find an estimate for a solution. Okay, so we can then get x1, and the way we do that is we have the equation that we're given and we substitute in the value. So that then becomes, if you type that in your calculator, all I've done here is substituted that value into there, and that gives me 1.709975, and they want us to do this 3 times. And then x2, do the exact same thing, but this time I'll substitute the previous answer in, so that's 1.709975, and that gives me 1.74244188, and then we have x cubed, and I'll do the exact same thing again, substitute the previous answer in, so that's 1.742488, and that becomes 1.73888495. Here are two right-angled triangles. Given that tan E is equal to tan F, find the value of x. So hopefully you've sort of straight away started to think about tan O over A. So if I label these, that's opposite, hypotenuse, adjacent, opposite, hypotenuse, adjacent. And then we can write tan E as tan E is opposite, which is x, over adjacent, which is 4x minus 1, and tan F can be written as 6x plus 5 over 12x plus 31. And now because these two are equal, we can write x over 4x minus 1 is equal to 6x plus 5 over 12x plus 31. And now, whenever you have fractions, you want to get rid of the denominators. So if you move over the 12x plus 31 to the left and the 4x minus 1 to the right by multiplying each side by 4x minus 1, and then multiplying the other side by 12x plus 31, that will give us x bracket 12x plus 31. So we've moved that way by multiplying each side by the denominator, and we'll do the same with the other one. So that's 6x plus 5. 4x minus 1, and if we expand this out, this is 12x squared plus 3 31x is equal to 24x squared plus 20x minus 6 minus 5, and now we can collect the like terms, and so you can subtract 12x squared from each side. So that gives us 12x squared, and then you can subtract 31x from each side, and that becomes minus 17x, because you can do the 20 minus 6, which becomes 14, and then 14 minus 31 gives you the minus 17, and then we have a minus 5 is equal to 0. And now we're looking for two numbers that multiply together to give us 60, that add or subtract to give us minus 17. And then that becomes 12x squared. Well, I can list them out as well, so that can be 2 and 30, and you'd sort of just go through that, 3 and 20, 4 and 15, and hopefully you can see we can stop right there, because the 3 and the 20 give us the 17. So we'll have a minus 20 and a plus 3. So we can have the plus 3x minus 20x plus 5 is equal to 0. And then we can factorize that as 3x bracket 4x plus 1 minus 5 bracket 4x plus 1 is equal to 0. And then we are trying to find x. X must be positive, so our answer. So if I collect the terms here, that's 3x minus 5. And then we have 4x plus 1 is equal to 0. So our answer must be this value here, which is 5 over 3, because this value here is going to be a negative 1 over 4, and x can't be negative because it's length. So moving on to the next one, 50 people were asked if they speak French, German or Spanish. Of these, 31 speak French, 2 speak French, German and Spanish. Okay, they've given us quite a bit of detail there. 2 of the 50 people are chosen at random. Work out the probability that they both speak Spanish. So I can straight away, hopefully you've started to think the same, that we need a Venn diagram. So let's draw a Venn diagram. There's going to be 3 circles because there's French, German and Spanish. I'm just going to copy this, paste that there, and paste it there. And I'm just going to drag this across like that. And that will do. And then I'm going to draw a box on the outside for any cases that don't fit. That could have been drawn a little bit better. No, it's not doing it for some reason. It does usually work. Come on. Okay, I'll give it one more attempt before I abandon it. Oh, there we go. Nice. So, something. Yeah, that'll do. So, there's 50 people altogether. We know 31 speak French. So let me just label some of these. So we have French, German, and Spanish. 31 speak French. There's not much I can do about that because it's only said French specifically. I don't know whether they speak any other language or not, so we'll skip this one for now. The next one says 2 speak French, German, and Spanish. We can put that, let me use a different color, that can go right there. That's very specific, so we can tick that one off. Then it says 4 speak French and Spanish, but not German. So that is going to go in here because they speak French and Spanish, but not German. We can tick that off. Now the next one, you want to be careful here. It says German and Spanish. So that is essentially looking at this entire loop here. I'll rub this off in a second. But that's looking at that entire loop. There's already 2 people in there, so this must be 5. Because it doesn't say, this previous one was specific. It said and not German. This one doesn't say and not French. So that's a 5 in there. We can take that off. Then it says 8 do not speak any of these languages. Nice and easy, that can go outside. And then it says all 10 people who speak German speak at least one other language. So the German circle is the top right one. It's already got 5 plus 2, which is 7. So that leaves us with 3 people, and that must go in here because it says they speak at least one other language. There's no one that speaks only German. So we can tick that off. And now coming back up to this one, if you look at the French circle, it's got a 3, 2, and a 4. If you add 3 and a 2, that's a 5 plus 4, which is a 9. So we can do 9 minus 31, and that means a 22 must go here. And that leaves us with, finally, there's 50 people altogether. If we add up everything we've got inside a square at the minute, it adds up to 44. That means a 6 must go in here, because no one speaks only German, according to the question. So that then leaves us with, what's the probability that they both only speak Spanish? So that must be 6 over 50, the first person. And now because they've chosen the first person, there's going to be one less to pick from the second time. And if you type that into your calculator, you get 3 over 245. Okay, so for the next one, we have been given a diagram, and it says prove that ADP is congruent to CBQ. Now, to prove something's congruent, they've got to have 3 sides that are the same, or 2 angles and a side that are the same, or 2 sides and an angle that are the same. So I'll first highlight what the question's asking us for. So they're asking us to compare. I should probably use a slightly smaller one. That one will do. It's asking me to compare this with this. Right, so prove. Okay, so I need to prove that. So I can see straight away that AD is equal to BC. So these 2 sides are the same because they're parallel lines. Parallel sides, same length. Cool, so they both share the same side. That's one side done. And I can see that so I can see that this angle and this angle are going to be the same because it's like as it is an alternate angle like that. Actually, now that I think about it, DAP is equal to BQC. Well, we can look at the obvious one first, to be honest. They've both got the same right angle. So we have got ADP is equal to QBC. Both have a right angle. And then the other side, that is the same because ABCD is a parallelogram. We can say that AP is equal to QC. So both sides are the same. And yeah, in this case, we have got 2 sides and an angle, so it's a congruent shape. And then it says explain why AQ is parallel to PC. AQ is parallel to PC because APQC is a parallelogram. So we can just write that APQCQ is a parallelogram, and the opposite sides are equal. So that's the end of the video. Hopefully you found this video useful, and I'll catch you in the next one.